The subject, the branch which deals with the principle of reasoning is called as mathematical logic. The truthfulness or falsity of a proposition is called the truth value of a proposition. These two statements can be connected to get a compound statement using logical connectives. So T and T is T, T and F is F, F and T is F, F and F is F. So true and true is true. In other cases, it is false. Hello dear students, welcome to this session of Mathematical and Statistical Computing class of first semester BCA. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to discuss regarding Unit 1 of Mathematical and Statistical Computing of first semester BCA of MYSURU University. Now, so you are going to study 4 units. In that 4 units, the first unit is the mathematical logic. You might have been studied this mathematical logic in your previous classes. Today I am going to discuss regarding what is meant by a mathematical logic and examples and the connectives, how the statements are connected using the mathematical logic. Now, let us know regarding what I am going to study today is, first one is what is meant by a proposition and the truth values and the logical connectives. How the propositions are connected to get a compound statement. So, let me discuss regarding what is proposition, what are the truth values and logical connectives, what are the logical connectives. Now, before going to that, let us know regarding the definition of a mathematical logic. What is a mathematical logic? Mathematical logic is nothing but it is a subject which deals with the principle of reasoning. The subject, the branch which deals with the principle of reasoning is called as mathematical logic. It is a mathematical process to arrive at valued conclusion using certain valued assumptions. They are called as the laws of logic. So, it is nothing but a mathematical process to arrive at valued conclusion using certain valued assumptions, and they are called as the laws of mathematical logic. Now, let us take an example. Bangalore is the capital city of Karnataka. New Delhi is in India. Root 2 is an irrational number. 3 into 4 is 12. These are all few examples, right? Now, let us know regarding what is meant by a proposition. Propositions and truth values. Proposition and truth values. Now, an assertive sentence which is either true or false. Just now I told Bangalore is the capital city of Karnataka. New Delhi is in India. Root 2 is an irrational number. 3 into 4 is equal to 12. So, they are all called as the proposition. An assertive sentence which is either true or false. Either it may be true or false, but both at the same time is not possible is called a proposition. An assertive sentence which is either true or false but not both at the same time is called the proposition. That means a statement which is either true or false is called a proposition, right? For example, 5 is a prime number and similarly root 2 is an irrational number. Bangalore is the capital city of Karnataka. So, they are simple sentences. Either it may be true or false. They are called as an statements. They are called as the statements. They are called as the propositions. Now, the sentences involving question mark or exclamatory sentences and expression of opinion are not considered as the proposition. So, the statements involving question mark, exclamatory sentences, interrogative sentences or opinion of comparison, they are not a proposition. Let us take for example, weather is pleasant today. Weather is pleasant today. Wish you good luck. These are not the propositions, right? Now, move on to the next concept. Now, how to write the truth table? Truth table for the connectives. What are the connectives? So, any two prepositions can be connected to get a compound proposition using the connective. What are the connectives? And, or, if then, if and only if, not. They are called as conjunction, disjunction, conditional, biconditional and negation. So, the truthfulness or falsity of a proposition is called the truth value of the proposition. The truthfulness or falsity. If it is true, we are going to represent it as T, and if it is false, we are going to represent it as false. This T and F are called as the truth values. The truth values are T and F. The truthfulness or falsity of a proposition is called the truth value of a proposition. The truth values of a true proposition is denoted as T, and that of a false proposition is denoted as F. So, T and F are called as the truth values. If the statement is true, then the truth value is T. If the statement is false, then it is denoted as F. Say, for example, let us take P. Root 2 is irrational. So, if it is true, we are going to call it as T. So, Q 4 into 3 is equal to 10. So, this is false. We are going to call it as false. So, T and F are called as the truth values. Right. Now, let us take few examples. Simple propositions is a statement which can be split up into two or more statements. So, that is by using logical connectives. Now, let us take for example, set of natural number is finite. New Delhi is in India. Here, these are the two statements. These two statements can be connected to get a compound statement using logical connectives. A compound proposition is made up of two or more simple propositions called as the compound proposition. So, here these are two simple propositions. These two simple propositions are connected using some connectives to get a compound proposition. Now, for example, I can connect this. Set of natural numbers is finite, or New Delhi is in India, or is the connective. Similarly, set of natural number is finite and New Delhi is in India, and is the connective. So, another example, if set of natural numbers is finite, then New Delhi is in India. That is called a conditional statement. One more connective, that is called as a biconditional. Set of natural numbers is finite if and only if New Delhi is in India. So, these are all the connectives. Using these connectives, we are going to combine two simple propositions to get a compound proposition. Let me take another example. If x belongs to A, y belongs to B, then x belongs to A union B. Here, x belongs to A, y belongs to B is a proposition, and x belongs to A union B is another simple proposition. So, they are combined together using the connective, right? X belongs to A, y belongs to B, then x belongs to A union B. And so, mathematics is easy or it is not raining today. Another example, here the connective we used here is or. Mathematics is easy or it is not raining today. Now, let us know regarding the connectives in details. So, the different types of connectives are conjunction, disjunction, conditional, biconditional. These are the four connectives which we are going to use to connect two simple sentences to get a compound statement or sentence. Now, conjunction, let us know regarding conjunction. The symbolic representation of conjunction is this, reverse V, that is P conjunction Q, P conjunction Q. So, the truth value of the compound proposition P and Q is true if both the components P and Q are true. In all other cases, it is false. So, first of all, the conjunction is denoted as P conjunction Q. This is conjunction. For any two statements P and Q, if P and Q both are true, then the conjunction P conjunction Q is true. In all cases, it is false. So, if P is true, Q is true, then P conjunction Q is also true. In all other cases, it is false. So, that means the truth value of a compound proposition P and Q is true if both the components P and Q are true. In all other cases, it is false. For example, let us take P. E is an vowel and Q, 3 plus 4 is equal to 7. Here, both the statements are true. E is an vowel and 3 plus 4 is equal to 7. So, both the statement, this is true and this is also true. Therefore, true and true is always true here. So, P conjunction Q is true. That is, if P is true, Q is true, then the conjunction P conjunction Q is also true. In all other cases, it is false. So, here P is true, Q is also true, that is E is an vowel, Q is 3 plus 4 is equal to 7. So, therefore, both the statements are true. Therefore, the compound statement P conjunction Q, if that is If P is true and Q is true, then P conjunction Q is also true. Now, let us write the truth table. How to write the truth table for conjunction? As I said now itself, in case of conjunction, true and true is true. In all other cases, it is false. So, write down the truth table for this conjunction. Write P, Q, P conjunction Q. So, for P, truth values are true, true, false, false, true, true, false, false. And for Q, it is alternative, true, false, true, false. So, conjunction, true and true is true. True and true is true. In all cases, it is false. So, true and true is true. True and false is false. False and true is false. False and false is also false. So, in case of conjunction, true and true is equal to true. In all cases, it is false. So, true and true is true. True and false is false. False and true is false. False and false is also false. This is an important table. So, how to write the truth table for conjunction? You will get 2 marks for this. Write the truth table for conjunction, or they may ask and here it is nothing but P and Q. P and Q. Right. Now, move on to the second connective, that is disjunction. Disjunction. So, the disjunction is denoted as B. So, how to write P disjunction Q? This is the representation, symbolic representation. So, the compound proposition P disjunction Q is false when both the components are false. If both P and Q are true, it is true. If P is true and Q is false, then also true. If P is false, Q is true, then also it is true. But if P is false, Q is false, then the entire statement is also false. That is, in case of disjunction, false and false is false. In all other cases, it is true. Let us take an example. Let P, root 2 is an irrational, 9 is a prime number. Here, P is a true proposition, Q is a false proposition. This is true. Root 2 is irrational, whereas 9 is a prime number. This is false, right? So, the compound proposition P disjunction Q, that means root 2 is irrational or 9 is a prime number, is true. Because for this disjunction, we are going to use R, P or Q. That means if P is true, true proposition, Q is false proposition, the conjunction, that is the compound proposition P conjunction Q is true, because root 2 is irrational or 9 is a prime number, right? So, first one is true and the second one is false. Therefore, the conjunction of true and false is again a true. Now, let us move on to the construction of a truth table. How to construct the truth table for this disjunction? So, P, Q, P disjunction Q, that is P R Q, R, P R Q. So, as usual, P, Q, P disjunction Q, true, true, false. For first two, true. Second two are false. Again, alternative, true, false, true, false, true, true, false, false, true, false, true, false. Now, in case of disjunction, false and false is false. In all other cases, it is true. False and false is false. In all other cases, it is true. So, true and true is true. True and false is true. False and true is true. False and false is also false. So, false and false is false. So, false and false is false, that is F or F is equal to F. In other cases, it is true. So, this is how we are going to write the truth table for a disjunction. Next connective, that is the negation. Negation, this is very important. The negation of a proposition P is not P and it is denoted as like this, not P. The negation of a proposition P is not P and it is denoted as negation of P. Let us take an example. Let calculus is difficult. What is the negation of that? So, calculus is not difficult. Calculus is not difficult. So, how to write the truth table for negation? So, P and negation of P. Suppose if the statement is true, then the negation of the statement is false, and vice versa. If the statement is false, then the negation of that false is true. So, P negation of Q. For true, the negation is false. For F, the negation is T. So, that means the negation is nothing but not. So, if P is true, then negation of P is not true, denoted as negation of P. Now, move on to the next connective, that is conditional statement. This is also very important, conditional. Now, conditional, If P and Q are two simple propositions, then the compound statement if P then Q. So here we are going to use if then and denoted as P conditional to Q, one arrow mark. That is if P then Q. If P then Q is denoted as P conditional to Q, like this. This is the representation of a conditional statement. So P conditional to Q is false when if antecedent P is true and the consequent Q is false. That means if P is true and Q is false, then the conditional statement is false. In all other cases, it is true. So that is, if P is true, Q is false, then the conditional statement is false. In all cases, it is true. That is, if P conditional to Q is false, if and only if the antecedent P is true and the consequent Q is false, and it is denoted as P conditional to Q, and in all other cases it will be true. How to write the truth table for conditional, that is implication? P, Q and P conditional to Q. As usual, for P the truth values are true, true, false. For Q, alternative true, false, and the conditional is true and false is false. In all other cases it is true. T and F is F. In all other cases it is T. T and T is T. T and F is F. F and T is T. F and F is also T. So that is true and true is true. True and false is false. False and true is true. False and false is also true in case of a conditional, that is if then. Next, that is if P is true, then Q is false, then the entire statement is false. Now move on to the next concept, biconditional. So biconditional, or it is also called as a double implication. How it is denoted as? This is denoted as biconditional to Q, or we can also write double implication like this, B biconditional to Q. That is, if P and Q are two simple propositions, then the compound proposition P, if and only if, denoted as P biconditional to Q, P biconditional to Q, is called the biconditional, or it is also called as a double implication. So the biconditional, P biconditional to Q is true when both the components P and Q are having the same truth values. If P is true, Q is true, then biconditional is true. If P is false, Q is false, then the biconditional is also true. That means if both P and Q will have the same truth values. In other cases, it is false. So, whereas P and Q having the same truth values, otherwise it is called false. So, if P and Q having the same truth values, then it is true. Otherwise, it is false, right? So, for true and true is true. True and false is false, false and true is false, false and false is also true, because P and Q will have the same truth values. Now, how to write the truth table for this biconditional? Biconditional means if and only if and only if, right? Biconditional. So, as usual, write down P, Q and P biconditional to Q. P, Q, P, true, true, false, false, true, false, true, false. So, in case of biconditional, true and true is true, true and true is true, and false is also true. These two are true. True and true is true, false and false is true. In other cases, it is false. True and false is false, false and true is false. So, true and true is true, true and false is false, false and true is false, false and false is equal to true. So, that is in case of a biconditional, right? So, in case of biconditional, true and true, that means if both P and Q will have the same truth values like T and T or F and F, then they are called true. In other cases, it is false. This is how we are going to write the truth table for a biconditional. Now, let us write the truth table for entire connectives. So, in the examination, they may ask one 6 marks question, write the truth table for conjunction, disjunction, conditional, biconditional and negation. So, conjunction. So, otherwise they may also ask, write the truth table for and, or, and means conjunction, or means disjunction, negation, not, then conditional, and biconditional. Conjunction, disjunction, conditional, biconditional and negation, or and, or, not, if, then, if and only if then, if and only if. Now let us write the truth table for all the connectives. Now truth table for logically connectives may be written like this: P Q, P conjunction Q, that is P and Q, P disjunction Q, then negation of P, then P conditional to Q, P biconditional to Q. So as usual for P and Q, the truth values are first for P, first true or true, 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 false, false. For Q it is true, false, right? So true, true, false, false, true, false, true, false. For conjunction, true and true is true. In all other cases, it is false. So T and T is T, T and F is F, F and T is F and F is F. So true and true is true. In other cases, it is false. Now for R or R, for disjunction, quite opposite. So if F and F, if both the statements are false, then only it is false. So F and F, then it is F. In other cases, it is true. So true and true is true. True and false is true. False and true is also true. False and false is equal to false. So here only one true, here only one false in case of a conjunction and disjunction. Not means opposite. So for true it is F, for true it is F, for F it is true, for F it is true. Negation means opposite, not. Then conditional. Conditional, what is the conditional here? For conditional statement, if first one is true and second one is false, T and F, then the statement is false. In other cases, it is true. So conditional, for conditional, true and true is true, true and false is false, false and true is true, false and false is also true. So true and true is true, true and false is false, false and true is true, false and false is also true. And the last one is the biconditional. In biconditional, if both P and Q will have the same type of truth values, then it is true. In other cases, it is false. So true and true is true, true and false is false, false and true is false, false and false is equal to false. So true and true is true, true and false is false, false and true is also false, false and false is also true. This is how we are going to write the truth table for a conjunction, disjunction, conditional, biconditional and negation. That is and, or, not, if, then, if and only if. Hope you followed, right? This is how we are going to write the truth table for all the connectives: conjunction, disjunction, conditional, biconditional and the negation. Hope you follow. So this is very important. Once if you know how to write the truth table for this, then easily you can solve the problems in mathematical logic. Hope you followed. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.